So, have you ever really stopped to think about what happens after you tell an AI to do something? I mean, how do you really know it got the job done? That's the huge challenge we're going to dig into today. How we can build AI agents that we can actually truly trust to complete their tasks.
Let me ask you this directly. When your AI agent comes back and says, "Yep, task complete," is it telling you a fact, or is it just kind of making an educated guess? The answer, as you're about to see, is way more important than you might think. Wow, this right here, this quote just nails the nightmare scenario, doesn't it? It's what keeps developers up at night. You get the green light, the thumbs up, the all good message, but deep down in the system, absolutely nothing has changed. This huge gap between what the AI thinks happened and what actually happened is a massive, massive problem.
Well, this common and honestly deeply flawed approach has a name. It's called the fire and forget problem. And it is right at the heart of why so many AI agents today are frankly just not reliable.
It's pretty much exactly what it sounds like. The AI gets a task, it fires off whatever command it thinks is needed, and then it just forgets about it. It moves on to the next thing, just assuming everything went perfectly, without ever, looking over its shoulder to check.
And just think for a second how incredibly fragile this is. A database can throw an error without making a peep. Two different processes could trip over each other in what's called a race condition. A service it depends on could just be down for a minute. In every single one of these cases, an AI using fire and forget is flying completely blind.
Okay, to make this crystal clear, let's walk through a super simple everyday task. We're going to ask our AI agent to do one thing: update a customer's email address in our database. Seems easy enough, right? So the agent does its job. It correctly figures out the command it needs to send, and it shoots it over to the database. Now, from the AI's perspective, its work is done. Mission accomplished. But here's the kicker, the thing that happens behind the scenes. A tiny, momentary network glitch happens. The command never even makes it to the database. It just vanishes into the ether. And of course, that customer's email is still the old one. Nothing changed.
And this slide just lays out the disconnect perfectly. In the AI's world, it was a success, but in our world, in reality, it was a total failure. This right here is the fire and forget problem in action, and it's exactly why you can't trust these kinds of systems with anything important.
All right, so if that's the problem, what's the solution? How do we build an AI that doesn't just cross its fingers and hope for the best? Well, we do it with this really elegant and powerful concept called the verification loop. I absolutely love this analogy from the source material. It's just perfect. A great chef doesn't just blindly follow a recipe and shove the plate out the door. No way. They taste the food. They check their work. They verify. Our AI needs to become that professional chef. The solution is this simple but brilliant four-step cycle. First, it analyzes the goal. Okay. Second, it acts on it. But here's the game changer. Step 3 is to verify. The agent has to actively go back and check if its action actually worked. And if it didn't, that takes us to step 4, correct or retry. It creates this perfect closed loop of responsibility.
So, that all sounds great in theory, but how does it actually work in practice? Well, the implementation uses a really clever idea inside the ReAct framework called paired tools.
The core idea here is basically a separation of powers. You give the AI one tool and its only job is to perform an action, say, writing to a database. Then you give it a completely separate tool whose only job is to verify that action, like reading from that same database. One to do, one to check.
So, let's bring this back to our email update example. The action tool is that update command. Its purpose is to attempt the change. But the verification tool is a select query. Its purpose is to go back to that database and confirm that the email was actually changed. You see the difference? One tool attempts, the other one knows.
And when you start building your agents this way, you're making a really fundamental shift. You're moving away from an AI that just assumes to an AI that truly knows. And that changes everything.
Let's just put it side by side. The old fire and forget agent is just making a guess, right? It's hoping for the best. But an agent built with a verification loop, it's not guessing. It has proof. It can stand there and definitively confirm that what it did had the outcome it wanted.
And why does all this matter so much? Because for any task that actually counts, managing customer data, processing financial transactions, controlling infrastructure, you simply cannot afford to guess. In a real-world production environment, this kind of verification isn't a nice-to-have.
It is an absolute necessity. At the end of the day, it really just comes down to this. The difference between an agent that thinks it worked and one that knows it worked, well, that's the entire difference between a system you can trust with your business and one you simply can't.
So I'll just leave you with this final thought to chew on. Once we have AI that can actually prove, with cold, hard data, that its work is done and done correctly, what new possibilities open up? What are those critical, high-stakes jobs that seem crazy to hand over today that you might finally be willing to trust to an AI? That's the future that verifiable AI makes possible.